challenging. Chemistry is challenging when you actually go for past paper. Okay. Now, topic number 4: introductory organic chemistry and alkanes. Contents, introduction, and alkanes. I will start from introduction. Organic chemistry is the chemistry of carbon compounds. I'm putting my introduction. So give the heading introduction. The first concept comes here. Organic chemistry is the study of carbon compound. You have studied organic chemistry in O level IGCSE Excel version, and you know that organic chemistry was initially related with the living objects compounds, but later this definition got a turn and they said every compound which contained carbon is part of organic chemistry. Some exceptions were there, like carbon dioxide, calcium carbonate. They are not part of organic chemistry, but normally every compound which contain carbon, alkenes, alcohols, phenols, aldehydes, ketones, benzene, they all are carbon families and they are called organic chemistry setup. Now, give the heading introduction and copy this screen.
Yeah, copied it.
Now, why carbon is considered in a separate branch? Carbon compounds are covalent in nature. Carbon bonds can be single, double, or triple, and carbon atoms can be arranged in straight chains. And if you remember it, I want you to recall with me. Do you remember this famous carbon chain? This one. This is where carbon has a unique property. Carbon atoms can be combined. Carbon atoms can be combined back to back in a chain. Carbon atoms form strong covalent bonds. They have a single bond, they have a double bond. Look, this was a double bond. And carbon is also capable of forming triple bond. So due to the variety, carbon is capable of forming so many compounds. Other atoms can be placed in carbon chain. So carbon can be combined with nitrogen, carbon can be combined with sulfur, carbon can be combined with oxygen. So carbon is a very social element. Carbon is a very social element and its compounds are in a huge variety. So it has to be separated. Now, special nature of carbon, which is called catenation. Carbon atoms are able to form in a straight line. You can join carbon atom in chains. These carbon to carbon atoms are joining together. This property is called catenation. This is called catenation. So now give a heading, catenation. Then copy this screen. So this is called catenation. Carbon atoms form a vast number of carbon compounds and they have an ability of chains, rings. So carbon form state chains, carbon form branch chains, and carbon also form rings. Carbon is capable of forming so many varieties. Then you have to copy this screen.
Yeah, copied.
Carbon atoms are able to form carbon atoms are able to form carbon atoms are able to form straight chains, branches, and rings. Rings are normally in A2, A level part 2. Normally, when you talk about AS, they normally focus on straight chains. And also, it is a case that when you talk about carbon capability, carbon is tetravalent. What is tetravalent? Tetravalent means that it is capable of forming multiple bonds. So carbon is capable of forming different bonds, variety of bonds. Then after that, the first one is a straight chain. Second one is a branch. And the third one is a ring. Straight chain, branch, and ring. So when you connect carbon in a straight line, look at this diagram. This is called straight chain. So copy now this thing. So these are the examples.
Okay.
Have you copied
Yep.
it?
Yeah, copied.
Good. These are called types of carbon structures which are commonly used, which are commonly in our course. Remember one thing, that organic chemistry is the study of carbon compounds. And why they are in a separate branch now? Because carbon is capable of making large number of compounds. Even families are there. So carbon compounds are so many in number that scientists had no other choice that they have to separate it in form of a separate branch in chemistry. Initially it was in the same area. Initially it was part of regular chemistry, but these compounds have no end. Virtually they can go infinite. Now you have to give a new heading: types of formulas. You have to give a heading: types of formulas. Types of formulas. Number one, molecular formula. Molecular formula like C4H10 is the exact number of atoms in the of each element. So it shows the real picture. What is empirical formula? It is the simplest whole number ratio of atoms in the molecule. I'm using butane in this example. Then you have to copy these two examples.
Yeah.
Let me know once you copy it.
Done.
Structural formula. This is a very important thing. A lot of MCQs are written in this format. It is the minimum detail showing version. You can see CH3, CH2, CH2, CH3. It can show in the bracket also. There are two possible structures of butane, which I have shown here. So these are called structural formulas. We have to copy this example.
Yeah, copied.
This is called structural formula butane. C for H10, straight chain, branched. I have shown already these two examples to you. The branches are in the side, in the middle, anywhere. These are called the branches. Now we have displayed formula. It shows all the bonds, complete picture of our compounds. It shows both the relative placing of atoms and the number of bonds between them. This is called displayed formula. You have to copy this.
Yeah, copied.
So these are called displayed formulas. Look at this one. This is called ethanoic acid, a famous compound frequently coming in the paper. And this is a compound which is an acid, organic acid. It's famous for use in just like an acetic acid, also called conventionally. You have to copy this example also. Have you copied it?
Just copying it. Those. Yeah. Yeah, copied. Yeah, copied.
Good. Skeletal formula. Skeletal formula is a simplified version, but many people find it very confusing, but it's getting very famous in the organic world. Organic chemistry is actually, organic chemistry is something which is present in lot of fields like medical science, like petrochemical and other fields. So organic is actually everywhere, dominant field. So the compounds are so many, so you can't draw these compound structures again and again. So we need a shortcut. Like in every field, like in languages, like in other field, we get a shortcut abbreviation. So this is a shortcut version. Look at this. This is actually ethanol, but a shortcut version. Now you have to copy this.
Yeah, copied.
And then copy this trial.
What compound is this, the name?
This is alcohol, C2H5OH.
Okay, done.
This is no, it's not C2H5. I'm sorry. There are 1, 2, 3, 4, 5. There are 5 carbons. This is called ring compound, cyclohexane and thalidomide. And cyclohexane is a compound which comes in our paper also. It is a ring compound. These are rings.
Okay.
We can write at least 4 condensed formulae.
Now look at this structure. It is called benzene C6H6, benzene, cyclohexene, and cyclohexene. These are compounds which are called ring compounds. These are also part of skeletal version. Now you have to copy this screen.
Yeah, done.
Now give a new heading, functional group. Now, do you remember functional group from O-level chemistry?
Yes.
What is a
Like
functional?
Like COOH, it basically gives the compound its properties, right?
Properties, identity. The main thing is functional group is able, a functional group is able to show the nature of an element. It is something, if the word functional means it is the part of an organic compound which is active during a chemical reaction. Organic compounds are very strange. The whole organic compound is never active. The whole organic compound is never active in a chemical reaction. A part of an organic compound is active, and that part is called functional group. So first write down the definition. Now, these are two examples. These are two examples, and the red color one, the red color part is the functional group. So now you have to copy this example screen, and I'm just coming, copy this example, copy this screen.
Yeah. Yeah, copied.
This is alkene group. Do not say double bond. This is our conventional language here. That when we say double bond is not. When you find out double bond in this group, in an alkene group, you have to say alkene group. Chemistry is too much formal. It's too much formal when organic comes. You have to copy this screen.
Yeah, copied.
Copy this screen.
Yeah, I copied it.
Oh, copied it. Good. Give this heading.
Yeah, done.
Now, what is a homologous series? The concept comes from the idea that organic compounds are huge in number. Virtually, there is no limit. Virtually, there is no limit of organic compounds. So it is just like a natural approach that when you say so many compounds, when you find so many compounds, you have to make groups. Like in a school, you make classes because you can't manage all of them in one go. So you make classes, then you make sections. Similarly, what they face that organic compounds are so many and increasing every day. So they made groups, families, a family of organic compounds with similar properties, chemical and physical. They are called homologous series, a series of compounds of similar structure in which each member differs from the next by a common repeating unit, CH2. Series members are called. So after giving the heading, you have to copy this screen.
Yeah, done.
To write under it, they contain the same functional group.
Okay.
Number one, hydrocarbons. Hydrocarbon means hydrogen and carbon combination. Alkanes,
Okay.
cycloalkenes, and arenes. I have changed the color for arenes because they're not part of AS. You have to copy this screen. Have you copied it?
Just copying it 1 second. Yeah, done.
This compound is an alkene, single bond, all single bonds.
Okay.
And there are 2 carbons. This is called ethane. You have to copy this screen now.
Yep, copied.
You have to copy this.
Okay. Yeah, done.
This is called cyclohexane. It's a ring compound. Remember, they both are the same. The right one is the detailed structure, and the left one is the summary structure. You have to copy this screen now.
Okay. Yeah, copied. Yeah, okay. Wait, go to the previous one, the cyclohexene. Hexene.
Cyclohexane.
There was another one in between this one. What's that?
This one.
Yeah.
Oh, this is benzene.
Oh, okay. Okay.
Achha, this one. Okay, you're talking about this one. This is benzene, and it has a ring structure. This is called benzene.
Okay.
C6H10 cyclohexene. It has one double bond, so it is called cyclohexene. You have to copy this.
Okay, done. Yeah, copied it.
Number 2, halogenoalkanes, alkyl halides, and halogenoarenes, aryl halides. You have to copy this name list.
Yeah, done.
This is called halogenoalkane. This is a halogenoalkane. It's a carbon chain with a bromine. There's a bromo, technically, it's a bromobutane. You have to copy this example.
Okay. Yeah, copied.
Now, this is called chlorobenzene. Now, you have to copy this.
Yeah, copied.
Hydroxy compounds, alcohols, including primary, secondary, tertiary, and phenols. You have to copy number 3 in list.
Okay, done.
Now, this is called ethanol. You have to copy this screen. Have you copied it?
Just copying it. Yeah, done.
So we keep it up to here. And please remember to arrange topical papers because we have done work and our practice is very little. And this will be a very big problem. So please try to do this in this week.
Or also, I a question instead of this Sunday class, if you have like a similar time to Tuesday free. Like in a working day?